with extensive plans by the government and utility providers to replace fossil fuel gas networks with both renewable natural gas and hydrogen, it is appropriate for us to consider the effect of fuel changes on the CHP system performance over the life of the project in our modeling process. CogenS enables the user to consider the CHP system fuel transition by entering the essential fuel properties needed in the modeling process on a yearly basis. After selecting the variable fuel option and choosing the units for our fuel properties input, we click the Import button and fill out the fuel transition table starting from year 1 and ending with the last year of the project life. The heating value, the fuel density, how the fuel affects the CHP rated output and efficiencies, the predicted fuel cost, and the fuel combustion CO2 emissions factor. We can fill out the table using an Excel sheet, then copying and right-click pasting in CogenS. In this fuel transition example, we are modeling a simple linear annual hydrogen-natural gas blend transition from 5% hydrogen to 100% hydrogen at 2040. We are linearly increasing the hydrogen percentage in the blend until natural gas is completely phased out. We can see the effect of hydrogen on the fuel heating value, output, efficiencies, cost, and emissions as we increase its concentration in the blend. The fuel density is used by CogenS only when the fuel cost unit is in dollars per volume or weight, depending on the fuel gaseous or liquid state. In this example, we are entering the fuel density in liquid state in pounds per gallon, but it will not be used by CogenS since our fuel cost unit is in dollars per kilowatt hour. All the table values must be entered in the same units chosen in the CHP input tab. For example, the fuel cost must be entered in dollars per kilowatt hour, the CO2 factor must be entered in pounds per MMBTU, and the fuel heating value must be entered in BTU per cubic feet. When done, all the values entered for year 1 in the fuel transition table are populated in the CHP input tab fields. The CHP rated output must be for a single unit of the system. In this project, we are using 3 units that are sized at 250 kW rated output each at year 1. If we needed to model CHP units replacement due to reduced capacity at a given year in our long-term study, we can always consider that by entering the rated output and efficiency changes in the transition table as shown. Then we can reflect the system units replacement in our model by importing a replacement schedule that lists the date and time of replacement and the system number of units. That way, CogenS will consider the replacement costs at the Financial Model tab. Now we can choose a fixed output control strategy and prevent a complete system shutdown by having at least 1 unit running at full capacity when the electric load is at minimum CHP loading capacity. Finally, we calculate our model. Here, we see that CogenS has calculated the monthly and annual energy production and consumption of the CHP and boiler systems. In addition, we also see the electric energy sent to and from the grid and CHP system waste heat. We also get the monthly and annual number of hours of the CHP system waste heat production and the number of hours of the boiler system operation, which is helpful in identifying utilization and capacity factors. We can generate a units report that details unit by unit performance in a monthly summary format and at every time step of the year. To see the CHP multi-unit operation, we go to the CHP Profiles tab and plot the electric energy production. We can immediately notice the frequent shutdowns in the first, second, and third quarters. To zoom into the plot, we can select the to and from dates, then replot the profiles. We can notice from this plot that the units have shut down 8 times in 1 week on average. We can also get a great visual of the electric and thermal energy distribution through an area plot at the electricity and heat NG profiles tabs. And finally, we can plot the total CHP microgrid project CO2 emissions and compare it to the conventional energy systems. If you like this video and looking for a one-on-one demo of CogenS, please reach out to us at info@jisenergy.com. Stay tuned for more videos like this on our website and YouTube channel.